All right, 2024 free response questions. This is question number 4. This is both an AB and a BC question. Number 4, let's take a look. The graph of the differentiable function f is shown in between -6 and 7, has horizontal tangent lines at x is equal to -2 here. Who knows if that's important? And is linear. Where are you going? Is linear in between 0 and 7. So you can see this is a straight line right there. Let R be the region in the second quadrant bounded by the graph of f. The vertical line x is equal to -6 and the x and the y-axis, so the shaded part there, of course. And it tells us that that has an area of 12. I know that is going to be useful. Okay, the function g is defined by, and we have ourselves an accumulation function here. Accumulation function because it's accumulating area underneath its f of x curve. Okay, so g of x is equal to the definite integral from 0 to x of f of t dt. And then also, just want to point out notation-wise, the difference in the variable here. So the variable, the independent variable for g is the upper limit of your accumulation function. So starting at 0, accumulating area here, and then it would be negated going towards the left anyway. And then the variable for the actual integral, though, is t. So this thing does not affect that. Find the values of g of -6, g of 4, and g of 6. I think that this is fairly straightforward in that each one of these is probably just worth a point, as in, hey, this looks like it's full 3 points. So I'll just step by step do each one of these little things. So on A, I want g, first of all, of -6. So g of -6, it looks like these bounds are going to be backwards. So 0 to -6 of f of t dt. I'm going to switch those limits of integration here, and when you do, that negates the whole integral, so negative integral from -6 to 0, f of t dt, and we're just going to pull this as area underneath this curve, which from -6 to 0 is just region R, which is 12, so this is the negative of 12, and there you have it there. I believe that is going to be the first point there. Okay, and then the next one, g of 4, this one rather straightforward, 0 to 4, there's nothing to fix here. F of t dt, again, we're interpreting this as area from 0 to 4. So from 0 to 4, that is this little triangle region right here. I think you should get purple. All right, so this is a little triangle. And they often do this on the calculus exam, understanding that definite integral is going to give you an area, give you a geometric shape that's pretty easy to find the area of, and expect you to connect the dots here. Okay, so that area is equal to 1/2 the base length, which is 4, times the height, which is 2. So cancel, cancel. This is just equal to 4. Meaning that my integral, or my g of 4, is equal to 4. Okay, and I think that that one's also the next point. And let's see, g of, last one here, 6. G of 6, one last guy, 0 to 6, f of t dt. Well, I can start with the first part of this, which is 4, because that's going to go from 0 to 4, so I'll start with that one. So this is 4 plus the integral from, let's see, it would be from 4 to 6, f of t dt. And let's see what that area is. So this one is underneath the curve. Since it's underneath the curve, this is going to be a negative signed area here, but it's another triangle. And so this guy's area is 1/2. My base length this time is 2. My height here is 1. So that's an area of 1. But it's not really 1, it's -1 since it's below the x-axis. So this should be a 4 minus 1 or a 3. Okay. And so I don't think that there's anything tricky that they're looking for there. Just each one of those 3 answers for the first 3 points. We'll verify that towards the end of the video. B, for the function g defined in part A, find all the values of x in the interval from 0 to 6 at which the graph of g has a critical point. Give a reason for your answer. So critical points come from where your derivative, in this case g, of x is equal to 0 or undefined. And we care about those, of course, because that's potentially where we have mins and maxes. It doesn't look like it's asking for that, but that's where they would occur if the question was just like a little bit different. Okay, so I am going to just kind of rewrite my g of x function. So g of x was equal to the definite integral from 0 to x of f of t dt. In order to find critical values, you have to take its derivative. So f or g prime of x is equal to, and this is the fundamental theorem of calculus. It's one version of it where you're taking the integral of an accumulation function, and it is essentially these things are inverses of each other. We're taking the derivative of an integral here, but there is a slight change in variable that this x is going to come in here. So this is f of x. Okay, and then in order to get our critical values, we need to set this thing equal to 0. So g prime of x equals f of x, which is equal to 0. And where does that happen? So we're just looking for x-intercepts of f of x, and I think there's only one, and that's this guy right here. It's at 4. So this happens at x is equal to 4. Why is this in red? I don't even know. At x is equal to 4. So I am going to say, like, it does ask for a reason here, right? So give a reason for your answer. So let's just make sure we write ourselves a little sentence or something. So I'm going to say, let's specifically, what does it say? At where find all values of x. So the graph of g of x has a critical point. Does it say point or value or whatever? Yes, it says point. Point at x is equal to 4, since g prime of 4 is equal to f of 4, which is equal to 0. Yep, that should do it. Let's see point-wise. What do we think? Okay, this is always a thing. And I'm making a connection here. This is using the fundamental theorem of calculus. I'm pretty sure that's going to be a point. And then, of course, actually finding x equal to 4, the actual answer with the reason, has got to be the other point here. So what are we up to? It looks like 5. We've got 4 more points. And let's look at the final part, part C. So the function h, oh yeah, let's go ahead and have another function in here. H of x is equal to another accumulation function, but this time we're accumulating area underneath the derivative of this guy. So from -6 to x of f prime of t dt, find the values of, and it looks like it's another 3 of these things, so another 3 points. But how many did we have? 1, 2, 3, 4, 5. So there's got to be another hidden point in here someplace. We'll try to figure out where it's going to be. So we're finding h of 6, h prime of 6, and h double prime of 6. Show the work. That leads to your answer. So make sure that you're not just given some kind of naked answers. Those answers have to be clothed in some calculus. Okay, so C, I'll write down the function that h of x is equal to definite integral from -6 to x. Let me just make sure. Yep. Of f prime of t dt. And I first want to find h of 6. There's a lot of 6's here. What's College Board trying to say here? 6, 6, 6. H of 6 is equal to the definite integral from -6 to 6 of f prime of t dt. Okay, so yeah, this is supposed to be area underneath this f prime curve, but unlike the stuff that we did in part A, I don't have a graph of this that I can compute the area of. So I got to tackle this a little bit differently. And that is, well, what would you do if you're just integrating, generally speaking? What you do is you'd find an antiderivative of f prime, which is f, so this is going to be equal to f of t, because if I take the derivative of this, I get that, and then evaluating this from -6 to 6, right? And then using fundamental theorem of calculus, the other one, I get f of 6 minus f of -6. And you know what? I bet right there, that's got to be the extra hidden point right there, because we had to use one form of the fundamental theorem of calculus back up here to show that the derivative accumulation function just switches that variable there and cancels out the integral. And this one is the other one where we're connecting antiderivative and then evaluating it at the endpoints and then subtracting for the second fundamental theorem of calculus. Or maybe it's the first one. Okay, so at this point, just go ahead and find f of 6. We have these values because it's just straight from the graph. F of 6, they even give us an ordered pair. It's -1. So this is equal to -1 minus f of -6. F of -6 is 0.5, so a -1.5 there. Okay, and that's probably a point. And we're looking for, I believe it's h prime of 6, right? Okay, so first of all, let me just find the derivative and then I'll plug that in there. So h prime of x, just like we did before, just fundamental theorem of calculus once again, this should be f prime of x, just a bit of a change of variable here with the integral canceling out. Now I'll go ahead and substitute in 6, f prime of 6. Okay, so this is slope here. So this is the slope of f at x is equal to 6. And I think that's why, in addition to like the area piece from before, why they gave us a line, so it would be super easy to find the slope here. So here's at 6, this is on that line, so all of this will have the exact same slope, so we just have to figure out what the slope is. It should be pretty easy. Just ask any Algebra 1 student. So going from here to there, I got to go down 2, and I got to go right 4. So my slope is down 2, right 4 is equal to -1/2. Is equal to, so remember 6 is equal to -1/2. Okay, that's got to be a point, of course. And we have one more, which I believe was h double prime of 6. Well, just like before, let's find h double prime of x first. And if I just piggyback on this one, if I take the derivative of h, I should get the derivative of f, which is f double prime of x. Okay, so now, I'll go ahead and plug in 6, f double prime of 6. Okay, whereas the previous one was the slope of f at 6, f double prime is going to be the concavity of f at x is equal to 6. And remember, it's a line. You remember, right? So at 6, even beyond 6, to the left of 6, all of this is a line, and a line has 0 concavity. In other words, if you had the equation of that line, which should be something along the lines of f of x is equal to -1/2 x plus, oh, we even have the y-intercept. Y-intercept, so we can write it exactly right. So it'd be something like that. You take its first derivative, you get -1/2, which we just used up here. You take its second derivative, and of course you get 0. That'll always happen for any kind of lines indicating it has 0 concavity. And so the concavity at 6 should also be 0. So h double prime of 6 is equal to 0, and that should be our final point. All right, so let's see how we did with the actual scoring guideline on this one and see if I guess the correct points here. All right, so on part A, it was worth 3 points, and you can see clearly that it was each one of the evaluations, g of negative 6, g of 4, and g of 6. So they had negative 12, they had 4, and they had 3. Let's see. Negative 12 and 4 and 3. Okay, so let's see if they said anything special about all of that with their little notes. Okay, supporting work is not required for any of these values. Huh, crazy. However, any supporting work that is shown has got to be correct to earn that corresponding points. Let's see, a special case. A response that explicitly presents does not earn the first point it would otherwise have earned. Oh, wait, because of the negative 6 that's there, right? Because the original thing didn't have the negative 6. No, it had 0, right? Okay, so someone's being brainless here and plugging in negative 6 there. The response is eligible for all subsequent points for correct answers for consistent works with supporting work. Labeled values may be presented in any order. Unlabeled values are read from left to right and top to bottom. So, for example, if you were racing through this and you just had your simple answers of, what is it, negative 12, 4, and 3, they're going to read it either from top to bottom, as this one is g of negative 6, this one is g of 4, and that one's g of 6, or they'll read it from left to right if that's the way that you ordered them. Okay, that's cool to know. All right, now let's look at part B. Part B, it was 2 points. Fundamental theorem of calculus. Well, would you look at that? So connecting that g prime of x is equal to f of x, and then having our answer with reason. And they said that, hey, this is equal to 0, x is equal to 0, therefore the graph of g has a critical point at x is equal to 4, which I'm pretty sure we said, right? I don't know, it's been a minute. Yes, that's correct. All right, so we were right with these 2 points. Let's see if they gave us any special scoring notes. First point is earned for explicitly making the connection that g prime is equal to f in this part. A response that writes g double prime is equal to f prime earns the first point, but can only earn the second point by reasoning from f being equal to 0. So that's, I mean, essentially you did need a fundamental theorem of calculus again in order to get that. Let's see, a response that does not earn the first point is eligible to earn the second point with an implied application of the fundamental theorem of calculus. For example, and there you go. A response that reports any additional critical points in between 0 and 6. Ooh, you lose the point. But this is weird. Any presented critical points outside of the interval will not affect scoring. Okay. All right, and then part C here. Last little bit. We have 4 points. Uses fundamental theorem of calculus again. So here this is connecting the antiderivative here and then subtracting at the endpoint. So that's a point. Finding h of 6 with supporting work, because remember it did say show the work that leads to your answer, which is the negative 1.5. A point for h prime of 6 was negative 0.5, and a point for h double prime of 6, which is equal to 0. Those I'm pretty sure we got. Let's see, 0, negative 0.5, negative 1.5, and then the FTC that I was just talking about. And our scoring notes include labeled values may be presented in any order. Okay. And then just like before, is if you don't label them, it's going to be read left to right in order or top to bottom in order. A response that presents only 1 or 2 values have to label them in order to earn any of the points. So in other words, if you only had 2 of those answers and you didn't label them, sorry, you're out of luck, because they don't know which one is which. Because did you do the first 2? Did you do the second 2? Did you do the first one and the last one? Who knows? All right, and let's say a response of h of 6 is equal to negative 1.5 does not earn either of the first 2 points. So not showing any kind of work just costs you some points. Response of h of 6 is equal to, and notice that they have the antiderivative here with the difference earns the first point, but not yet the second point. I think to get the second point, you actually have to have the number as the answer, of course. Pulling stuff from the graph, response of h of 6 is equal to -1 minus 0.5 is the minimum work required to earn the first, both of the first 2 points. So this apparently is making an implied connection between the difference of these two, f of 6 and f of -6. To earn the third point, a response must either state that h prime of x is equal to f prime of 6 of x, or what we wrote here, that h prime of 6 is equal to f prime of 6. And did we say that? I want to make sure we did that so we get the point. I'm pretty sure we did. Yeah, well, yeah, it's right there. Okay. And so that's part of the work that they're looking for, and and provide that answer. The fourth point is earned for a response of h double prime of 6 with or without supporting work. Oh, so they had a little bit of an exception there. A response that has one or more linkage errors does not earn the first point it would otherwise have earned. So they explain what they were talking about here. This is what a linkage error is. So here you have an x, but then you link that to specifically f prime of 6. Well, the derivative is not equal to just the derivative of 1 point. It's supposed to be changing, so that's a linkage error. So they would not give you that point, but is eligible for the fourth point even in the presence of other linkage errors. So in other words, if you made the mistake once, they don't just continue to deduct points from you. Okay, so that should conclude this calculator inactive, both A, B, and BC question, really, which was more or less about the fundamental theorem of calculus, finding some area underneath the curves and stuff like that.